So as I said at the end of the last video, sine and cosine, since they're both periodic with period 2 pi, when you're working with sine and cosine, it's enough to work on any interval of length 2 pi. What people focus on is this interval when working with sine and cosine. So we're going to do the same thing. Keep in mind we're in radians now, okay? Generally, when you're working with sine and cosine mathematically, people focus on radians as the unit for the angles. So that's what we're going to do. Okay, now we can use the fact that they're periodic to evaluate the trig functions at certain angles. For instance, let's look at cosine of 17 pi over 4. You know, that's not obvious. How are we going to calculate that? Well, notice that 2 pi, that's the same thing as 8 pi over 4. Okay? 8 pi over 4. Now, what does that tell us? Well, that tells us 17 pi over 4 is outside this interval. Okay? It's too big, in other words. All right, well, what do? What we're going to do is we're going to subtract 2 pi from 17 pi over 4 enough times until we get a number in this interval. So it's almost like you can imagine everything we know about sine and cosine, we know everything about them in this interval. And this example is demonstrating how we can use that knowledge to evaluate sine and cosine at any number outside that interval. So for instance, we have 8 pi over 4, right? Okay. So if we have 17 pi over 4 minus 2 pi, which is 8 pi over 4, we're going to get 9 pi over 4. Okay, now that's still too big though. Okay, what do? Let's subtract again. So we have 9 pi over 4 minus 8 pi over 4. We get pi over 4. Now, how does that help us? Well, altogether, we have cosine then of 17 pi over 4. That's going to equal to cosine, see if I can fit this, of 17. I'm not going to fit it there, so let me erase this. It's going to be cosine of 17 pi over 4 minus 8 pi over 4. And that's, of course, cosine of 9 pi over 4. And that itself is equal to cosine of 9 pi over 4 minus 8 pi over 4, which is cosine of pi over 4. So altogether, we're trying to calculate cosine of 17 pi over 4. We're using the fact that cosine is 2 pi periodic. And we have cosine of 17 pi over 4 is equal to cosine of something in this interval. In this case, that something is pi over 4. And we know what cosine of pi over 4 is. That's equal to the square root of 2 over 2. So altogether, cosine of 17 pi over 4 is the square root of 2 over 2. So using the fact that cosine is 2 pi periodic, we were able to calculate cosine of an angle that was outside this interval. Let's do the same thing with the next trig function, with cosecant. Now, cosecant, remember, is itself 2 pi periodic as well. The only trig functions that are not 2 pi periodic are tangent and cotangent. Their period is pi. So really, by the same calculation as above, this is going to be the same as cosecant of 9 pi over 4. And that's the same as cosecant of pi over 4. So we know that cosecant of 17 pi over 4 is the same as cosecant of 9 pi over 4, which is the same as cosecant of pi over 4. Okay, and again, that's just the same kind of calculation up here because it's also 2 pi periodic. Now, what is cosecant of pi over 4? Well, if you remember, cosecant is 1 over sine. So this is 1 over the sine of pi over 4, which is equal to 1 over sine of pi over 4 is radical 2 over 2. Okay, now that's really not the best way to write the answer, but we can write it in a better way. Namely, this is the same thing as 1 divided by radical 2 over 2. And when you're dividing, what do? When you're dividing a fraction, you flip the second fraction. In other words, and then you multiply. So this is 1 times 2 over radical 2. And so we get 2 over radical 2. So that's what we get there. Here's another example. We have sine of 5 pi. And of course, 5 pi is definitely, let me write the interval down here, is definitely, again, this is the interval we're working on. It's greater than 2 pi. Okay, so let's do what we did above. We're going to have 5 pi. If we were to subtract 2 pi, we're going to get 3 pi. Now that also is outside this interval, so we're going to subtract 2 pi again, and we're going to get pi. Okay, so that's good. So that tells us that sine of 5 pi is equal to sine, see if I can write this, of 5 pi minus 2 pi, which is sine of 3 pi. And that is equal to sine of 3 pi minus, see if I can erase that, put it 2 pi, which is sine of pi. And so it's almost like we know everything about sine and cosine in this interval. Outside the interval, right, if we have a number outside that interval, using the fact that sine and cosine are periodic, we're reducing it to sine of or cosine of a number in this interval. So sine of pi, we already know what that is, right? That's equal to 0. Okay? You know, just in case you forgot, right? If you go back to, right, the unit circle definition, right? The angle pi in standard position looks like this, okay? Pi, remember, is the same as 180 degrees. Okay, so I'm writing everything now in radians, right? And then if you were to look at the unit circle, see if I can draw that, although it's not going to be pretty, but I'll try. The unit circle, basically, that P, is going to be the point -1, 0. Sine is always the y-coordinate, so we get 0. That's what happens here. Okay, now here's some other properties about sine and cosine. If you remember, we talked about what it meant for a function to be even or odd. Just to review, you have a function f, let's say, is odd if for every x in its domain, negative x is in its domain, and f of negative x is this, negative f of x. Okay? That's what it means for a function to be odd. For even, the only difference is that f of negative x is f of x. So that's what even means. Of course, again, we're also assuming that for every x that's in the domain of f, negative x is in there as well. Well, it turns out that sine and cosine, it turns out that sine, as you can see here, is odd. Cosine right here is even. I mean, you could also determine, as we have here, if tangent is odd or even, it's actually odd. Same thing with the other trig functions. But it's really enough to know sine and cosine because you can express all the trig functions in terms of sine and cosine. Okay, now why is sine and cosine, why is sine odd and why is cosine even? It's actually not hard to show. Suppose we have, I mean, I guess you would have to take it case by case, but let's just consider this. Let's suppose this was our angle theta, so it's in standard position. Well, negative theta, right? The only difference is that negative theta is going to be rotated clockwise, right? If you negate an angle, you're rotating it in the other direction. Okay, so this is negative theta. Okay, Now, if we were to draw the unit circle, see if I can do this. It's kind of hard to see from the picture I drew, but hopefully you'll understand what I'm doing. So this is our point P, right, which is x, y. Well, it turns out that this point P down here has coordinates x, negative y. So in other words, for negative theta, the point P corresponding to negative theta has these coordinates. They have better pictures in the textbook, so be sure you're looking at the book. But this implies that if you did sine of theta is x, not x, what am I saying? That's y. And if you did sine of negative theta, that's actually equal to negative y. Okay? So in other words, we have from here, negative sine of negative theta is y, and so sine of theta is negative sine of negative theta, which is equivalent, of course, to saying this. You just move the negative, so to say. But basically, this is how we get this. Cosine is similar. The only difference with cosine is that the x-coordinate doesn't change. In other words, cosine of theta we have is x, and cosine of negative theta is also x. Hence, cosine of theta is cosine of negative theta. So cosine is even. Okay? I mean, again, there are better pictures in the textbook, so be sure you're reading the textbook as well.